Hi to everyone. This is Dr. Vijaya Vardhan. In this session, we are going to see the cloud computing basics. The following are covered in this session of cloud computing basics. The first one is cloud definitions, service model architectures, deployment models, foundational elements of cloud computing, and platform virtualization. So let us look at what is cloud computing. See, cloud computing is a model, or you can say a scalable distributing computing environment which will provided as a service or delivered as a service to customers as pay-as-you-go manner over the internet. If you look at the evolution of cloud and then future of computing, and the next decade is going to be future for the cloud, and the disruptor here is virtualization. And a working definition of cloud computing as per NIST, cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources such as networks, servers, storage, applications and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Then cloud computing model also enables an enterprise to be truly agile so that it can deliver an infrastructure that is flexible, scalable, and most importantly economical by efficiently utilizing the underlying physical resources. This cloud model promotes availability and is composed of 5 essential characteristics, 3 service models, and 4 deployment models. So let us look at the 4 deployment models, which are private, public, hybrid, and community. And service models are software as a service, platform as a service, and infrastructure as a service. And essential characters are measured service, rapid elasticity, on-demand self-service, broad network access, and resource pooling. So if you look at service model architecture, the top one will be the software as a service, followed by the platform as a service, and the base one is the infrastructure as a service. And in software as a service model, the software is provided as a service, and this is the topmost layer of cloud computing stack directly consumed by the end user. And the provider's application is running on a cloud infrastructure and is accessible from various client devices through a thin client interface such as web browser. Then SaaS is a recurring subscription based model delivered to the customer on demand, like pay as you use. And then best SaaS examples are Salesforce CRM, Google Apps, Zoho Support, Deskaway, Impel CRM, and Wipro SaaS. And the platform as a service, the platform has been provided to the end users to deploy or the consumer created applications using different programming languages, and there is no need to download any software. And as per the definition, you can see the capability provided to the consumer is to deploy onto the cloud infrastructure consumer created application using different programming languages. And this path has definitely empowered small and mid-sized companies or even an individual developer to launch their own SaaS, leveraging the power of these platform providers without any initial investment. And past layers are Cloud OS, Cloud Middleware. You can see Google App Engine and Windows Azure are example of Cloud OS, and OrangeScape, WolfPass or Cloud Middleware, and Windows Azure can be seen as SaaS plus and Windows Azure can be seen as iOS plus PaaS. And infrastructure as a service, where the cloud will provide an infrastructure where the consumer is able to deploy and run arbitrary software which can include operating systems and applications. And this is the base layer of cloud stack. And let us try to understand this using Amazon EC2. In Amazon EC2 Elastic Compute Cloud, your application will be executed on a virtual computer or virtual instance. And you have the choice of a virtual computer where you can select a configuration of CPU, memory and storage that is optimal for your application. The whole cloud infrastructure, servers, routers, hardware-based load balancing, firewalls, storage and other network equipment are provided by the infrastructure as a service provider. The customer buys these resources as a service on a need basis. And the 4 cloud deployment models are private, public, community and hybrid. The private cloud is enterprise owned or leased. It is managed by the own organization or third party. It may exist on-premise or off-premise. And then community cloud is shared infrastructure for specific community. Example, mission, security requirements, policy and compliance considerations. Then public clouds are sold to public and this is a mega scale infrastructure. Then hybrid cloud is composition of 2 or more clouds. The cloud infrastructure is composition of 2 or more clouds, private, community or public. And this remain as a unique entities but are bound together by standardized or proprietary technologies that enables data and application portability. Examples, cloud busting. And we'll see the foundational elements of cloud computing. In this, the primary technology is virtualization. The virtualization is an abstraction layer for running different operating systems and different applications from physical layer. And this is a base or primary technology we can say, and which is very important in the development of cloud model. And apart from virtualization, we have a grid technology and service-oriented architectures, distributed computing, and broadband networks, browser as a platform, and free and open source software. Apart from these primary technologies, we have other technologies such as autonomic systems, web application frameworks, and SLAs. And if you look at platform virtualization, this is a very, very important aspect in the cloud computing, because cloud computing separates the application from the underlying infrastructure. Because now to run multiple operating systems or multiple applications, we need to have a virtualization technology. So virtualization technology enables to run different operating systems. So the host operating system provides an abstraction layer for running virtual guest operating systems. So here the hypervisor is the key. What is hypervisor? Hypervisor is a software layer which sits on the underlying physical hardware and enables multiple guest operating systems to run above it. So it enables guest operating systems to run in isolation of other operating systems, and it runs multiple types of different operating systems or multiple instances of same operating systems. So because of this hypervisor or this, which use the virtualization technology, which increases the utilization of physical servers, and this enables the portability of virtual servers between the physical servers. Concludes the basics of cloud computing, and watch this space for more videos to come on the cloud computing.